Line 1, and we are going to be doing our first type of conic section, graphing them, looking at their equations. And the conic section we're going to look at today is called a parabola. Here is your definition of a parabola. It is the set of all points xy in a plane that are equidistant from a fixed line, the directrix, and a fixed point not on the line, which is called the focus. All right, let's go ahead and look at what that is. So let's go ahead and I'm going to give us a parabola here just at the origin. All right, so what we have is we have this point on the inside of the parabola. Let's put it here. This point is called the focus. Let's call it F. And then what we have is we have a line that is called the line of the directrix, and it runs horizontal. It's called the directrix, and it's equidistant from the vertex here of my parabola. So we've got the vertex, we've got our focus, and the line of the directrix. Now here's what the definition of a parabola is. It's the set of all points that lie on the parabola, and every point on the parabola is equidistant from the focus and the line of the directrix. Now it's not going to look like it here on my drawing, but every point that we find here is going to be equidistant from both the point and the directrix. So all of these points, if I have a point here and I slide it around the parabola, it's always equidistant from those two. That's what the definition of a parabola is. We've got a lot of different forms of the equation of a parabola, and so we're going to first start with what standard form is. Standard form, and this would be for a parabola that either opens up or down, looks like this. X minus h squared equals 4p, and p is something that we're going to talk about in a little bit, y minus k. So this is a parabola that opens up or down. Your x's are being squared. All right, and if you have a parabola that opens left or right, then it looks like this. Y minus k squared equals 4p x minus h. So those are called standard form, and when we go to graph them by hand, we're going to go back and look at some of the more important parts to this standard form. But let's go ahead and talk about one part, and that is the vertex of our parabola is h comma k, and it always will be. And your h and your k are always the opposite sign. And the direction that the parabola opens, it depends on whether or not you have a negative or a positive. And if it's positive, it opens up. If it's negative, it opens down. And same with the right and the left. It kind of goes with the standard form of our x and y axis with positive and negative numbers. All right, we also have what's called vertex form, and so this is for opening up and down, what the vertex form would look like. Vertex would be y equals 1 over 4p times x minus h squared plus k. What you're probably familiar with is the x minus h squared plus k. The 1 over 4p is actually the number that would tell us how our parabola would open and how wide it is. All right, left and right. Your form is x equals 1 over 4p times y minus k squared plus h. It's a k value. And in all of these cases here, your p-value cannot be equal to 0. All right, we got one more form here, and it's called general form. Your general form is y equals ax squared plus bx plus c, and this is for up or down, and x equals ay squared plus by plus c, and this is left or right. All right, so those are all your forms. Now what we're really going to do is look at how all of this plays, because we're going to have to graph these parabolas in any of the forms. With that, we have a couple definitions. One of them is the focus. The focus is a point that is p units from the parabola's vertex. So if this is my parabola, and this is the vertex, and this is my focus, then what this is telling me, and the focus is always on the inside, the interior, then this distance is p units. Well, the p comes from our formulas. Okay, now the definition of a directrix. The directrix is a linear equation that is p units from the vertex. It lies on the exterior. This is your interior, and this is your exterior. Your directrix is going to be a line that is the same distance away, p units, but just on the other side. And it's a horizontal line or a vertical line, and it's going to depend on how the parabola opens, if it's up, down, left, or right. And we will also look at all of the different types of parabolas. All right, here are all your parabolas. So let's say I've got a parabola that opens up. Then here's what I know. The focus is on the inside. I'm going to call it F. The directrix is a line horizontal to it, the same number of units below. So what we've got is this measure right here is the same as this measure. Okay, that's for a parabola opening up. Also, what we know is that our p-value here is positive. Okay, let's look at a parabola opening down. Our p-value is going to be negative. The focus is on the inside, so the directrix would be above it, but the same distance away. These would be the same measurement. All right, let's look at one that's opening to the right. The p-value would be positive. This time my focus is again on the inside. This is my focus, and my directrix would be a vertical line on the exterior. And again, this distance between the focus, vertex, line, vertex, these are the same. These are equidistant. These are all equidistant. All right, last parabola. Let's find one that's opening to the left. And one that's got a focus then. The focus would be on the inside. And then my directrix would be a vertical line on the other side. And then these measures would have to be the same. This measure is the same as this measure. And that's what we know about these parabolas. Now, just to give you an idea of what these equations would look like, here you go. So this first equation, it opens up, my p is positive, the vertex is at the origin, so this equation for this first one is x squared equals 4p times y. P is positive. Here I'd have x squared equals negative 4py, and that coefficient would be negative. On the bottom here, I've got one that's opening to the right, so it's y squared equals 4px, positive p-value, and the last one would be y squared equals negative. We want this to be a negative coefficient, 4p times x. So all of these here, also with this form, I just showed you all four of these in standard form. Standard form. It's time to look at a full example. Let's go ahead and do this. My first example that I have is name the vertex, focus, directrix of the parabola given by this equation. Well, you can see here we have an 8 that's supposed to be in front. So let's go ahead and put this 8 in here. All right, well, this is in vertex form. And I'm going to remind you what vertex form here looks like. Let's go back. Here's our vertex form. Y equals 1 over 4p x minus h squared plus k. So I'm going to write that down. Y equals 1 over 4p x minus h squared plus k. So let's find our vertex. Our vertex is hk. So our vertex here, this is my h value. This is my k value. The h would always be the opposite of, so it's 2 and then 3. Let's find our p value. Well, I know that this coefficient in front has to equal 8. So I find my p by saying 1 over 4p equals 8. So 1 equals 32p, and p would equal 1 over 32. All right, so we've got our p value, and we actually will, we're going to go ahead and try to start sketching a graph to this. Here's where my graph would be. I'm going to go ahead and put it right here. My vertex is 2, 3, so 1, 2, up 3. Because my 8 is positive, it's going to open up. And the point here, so I know it's going to open up like this. My point, or my p value, my p is 1 over 32, and what that tells me is where the focus is. So remember, the focus is on the inside here. My focus would be 132, 130 seconds distance above this focus, or this vertex, I mean. So I need to take my vertex, and I need to take my y value, and I need to add 1 over 32. Okay, well, my vertex, the y value is 3, so I still go over 2, and then I got to go all the way up. So it's 2, 3, and 1/30 seconds. I added it to it. So then, in order for me to find my directrix then is the same measurement, but down below the parabola. So I have to subtract 1/32. So it'd be, my equation of my directrix would be y equals, I need to subtract 1/32 from the 3. So it's 2 and 31/30 seconds. And that's how you identify all your parts and how you sketch your graph. All right, that's going to be the end of that sketch. And we got one more part to this problem here, and then I will probably start a second video. Let's take this same equation here, find the general form of the quadratic equation. Find the general form. Well, general form is this: y equals ax squared plus bx plus c. So what they're wanting me to do here is FOIL, distribute, and add like terms. So we can do that. I'm going to FOIL the x minus 2 squared, x squared minus 4x. You got to double your middle term, plus 4, and then plus 3. So this is y equals 8x squared minus 32x plus 32 and plus 3. So final answer, y equals 8x squared minus 32x, and that's plus 35. This is your form, general form for a quadratic. All right, so this is going to be the end of the first video.